Hi, I'm Bo. I'm the CTO and co-founder of BlinkAI Technologies. Over the next few years, we're going to see cameras going everywhere, being deployed on all sorts of devices and vehicles in multiple growing markets. And while that's very exciting, one of the big problems is that most of these cameras are going to be weak in terms of their performance in low light. And the reason is because camera sensors are getting smaller and smaller to become lower cost, and often they have to be smaller physically in order to fit onto these often mobile devices. And so that's causing less light intake, right, into the camera sensor. And particularly as the end user application still wants to be very high resolution, like 1080p or 4K or even higher, that means that you're subdividing a sensor that's already small into even smaller subcomponents. So every pixel is having less light intake. And that's a real problem when it comes to dark conditions where it's already very dark. And so the current algorithms now give us pretty poor quality images. And it's not just humans that look at these images and don't like how they look, but as more and more of these sensors, again, are being placed on devices and now vehicles, there's real, sort of safety concerns that begin to pop up. And so, in this slide here, what we see is a frame from the onboard video of the now infamous Uber self-driving car crash that happened last year. As you can see, the pedestrian that this car was about to hit, just 1 second later, was unseen by the camera because the person was beyond the headlights. And therefore, the object detection system failed and caused the crash. And when you think about ways of trying to improve the situation, the traditional approach is to just get more information into your camera system, right? So that means increasing the size of your sensor or increasing the size of your glass lens that's capturing more light. These are all very sort of expensive hardware compensations. Our approach is a complementary way to improve our imaging in low light, and that's computationally. And with the same information that we already have, we can do far better in terms of processing it. And it's really inspired by how we as humans learn how to see, actually, so through this process called perceptual learning. And because our brain is sort of always training itself in terms of how best to interpret the raw neural signals that are coming in from the brain, we have this amazingly efficient biological vision. So with our technology, AutoMap, what we do is we recapitulate this process and using artificial neural networks, place this perceptual learning paradigm into camera sensors, putting a brain behind the camera sensors, essentially, really improving, at the end of the day, the performance of digital imaging sensors by 5 to 10-fold. So we published the fundamental aspects of this technology in Nature last year, and since then it's received significant attention in the scientific community and in the media. And now we've spun it out as a company at BlinkAI, really enhancing the performance of digital imaging sensors. And what you can see in this slide here is how we perform compared against the sort of traditional image signal processing algorithms. On the left, we see Samsung S9 Plus default JPEG of a pretty dark scene at 0.5 lux. With the same exact raw data, we see that BlinkAI on the right is able to substantially improve the performance, really being able to see a lot more details, a lot more accurate in terms of the colors. And we've also now extended this from photography into video. And so in this case, we see in this slide is the same sort of comparison between the left and the right side on the same raw data. And also now what we've done is we've overlaid a state-of-the-art object detection system. And what we see is that purely by enhancing the image, purely enhancing the image frames of the video, we get substantially improved object detection performance. And so this is going to be really helpful for cars and ADAS sensors and autonomous vehicles that are trying to see people better at night. On this slide, we see also single frame high dynamic range using the same machine learning platform. On the left-hand side, it's hard to see the person, until they're directly in the light, whereas on the right-hand side with BlinkAI technology, we see the pedestrian from the very beginning in the shadows. So, To summarize, our key value propositions are that we have a proprietary machine learning platform to maximally extract imaging data in low signal environments. In terms of compatibility, it's really important because we're compatible both with upstream imaging hardware, so you don't have to change your camera sensors, and we're also compatible with downstream AI, perception AI. So you don't have to retrain your object detection and other computer vision algorithms as well. Price point wise, it's really low cost computation compared with much more expensive hardware solutions trying to increase your sensor size or your lens size. And there are multiple growing markets that desire this improved low light performance because of the trends that we've been talking about earlier. So that's BlinkAI, and if you're interested, don't hesitate to contact us.